All right, so today's lesson is going to talk about simplifying radicals with following all three conditions. So far we've been working on just condition number 1, which told us that we cannot have factors that are perfect squares inside our radical. So that's the one we've been working on so far. We're going to learn 2 more. Now, before we start this though, I want you to make sure you understand a few things that are allowed to do when you have a fraction, which we've kind of talked about. So if you take a look at this, the square root of x over y, that really just means the square root of x over the square root of y. This is helpful because if I have something like this, the square root of 41 over 49, I can take this problem and I can split it into the square root of 41 over the square root of 49. And then condition number 1 says that none of the radicands can have perfect squares in it, so we know the square root of 49 is 7. So then we would make this the square root of 41 over 7. Now, of course, when you have a fraction, you should always reduce your fraction first. So for example, all of these fractions, we would just go through and reduce them all. So let's do a couple together, and then I'm going to have you do a few of them on your own. So go ahead and take the very first fraction, 12 over 20. Well, that reduces to 3 over 5, because you can divide those by 4. So you have 3 over 5. And then n to the 7th over n to the 3rd, well, you would subtract your exponents and end up with n to the 4th. Now, rather than write the radical over the entire thing, let's just split it up now. So then I can write it as the square root of 3n to the 4th over the square root of 5. And once I'm done with that, then I have to look inside my radical, and I can see that n to the 4th is a perfect square. So I have to find the square root of that. So this would end up being n to the 2nd square root of 3 over the square root of 5. Let's try the next one. So the next one, rather than start simplifying 30 or simplifying 27, reduce the fraction. 30 over 27, that can all be divided by 3. So you would make this the square root of 10 over the square root of 9. And since the square root of 9 is 3, you would have to simplify that to the square root of 10 over just 3. Now take a moment to stop the video and try C, D, E, and F on your own, and then come back to see if you've gotten them right. So here are the correct answers. Take a moment to check your answers. If you didn't get these answers, then perhaps look at the step that you did before that. Maybe you have what I have. So mistakes that people commonly make is people stop right here, say for letter E, c to the 3rd, well, that has a perfect square that goes into it, so you'd have to break it up into c squared times c, pull out the square root of c squared, and that's c. The other thing right here, y squared, people often forget. If ever you have a variable with an exponent on it, it's not in simplest form. You have to pull out the square root of the closest even to it, and that one was even, so I had to pull out the y. All right, so the reason I asked you to do this is because this is going to be really helpful whenever we're dealing with problems with fractions. Now, the next condition that you have to follow is that there cannot be fractions inside the radical. So that's the next thing. We can't have fractions inside the radical. So I've given you some steps on what to do if you have a fraction, because if you look at these, all of these are fractions. Well, the first thing you want to do is simplify the fraction, because you might end up without a fraction, and then you could do the problem. If it's still a fraction, then you do the little trick we were doing before. You just split it into 2 radicals, one for the top and one for the bottom, and then you simplify those radicals, which was basically what we were doing up there. So here, if I go ahead and do the square root of 32 over 2, well, let's divide that first, and you get 16. So this would give me the square root of 16. Well, and we all know the square root of 16 is 4. So we're finished with that problem. Now the next one, 21 over 28, well, I would first start by reducing that fraction. They're both divisible by 3, so I'm sorry, by 7. So then I would divide by 7, and I would get the square root of 3 over the square root of 4. It would be the square root of 3/4, but I went ahead and just split it up because it's still a fraction. But now the radicand is no longer going to have, or is going to be a fraction, because the square root of 4 is 2. So I'm now going to say it's the square root of 3 over 2. And that would be your final answer there. Let's try one more. So this one, the square root of 40 over 5. Well, I would reduce that. 40 over 5 is 8. So then now you no longer have a fraction. It's the square root of 8. But I have to simplify that because 4 is a perfect square. It goes into 8. So you're going to make this the square root of 4 times 2. And then you pull out the square root of 4, which is 2. So then this answer is 2 square root of 2. Go ahead and stop the video and try the next 3. And then tune back in and see if you've done them right. All right, go ahead and double check your answers to the last 3. I wanted to point out that, just a quick reminder, that when I reduced all of this, it was no longer a fraction, but then what I did is I had to split that up into a perfect square, and then this I broke up into a perfect square times x, and then y to the 6 was already a perfect square. So I'm circling my perfect squares, the square roots of those came out, and I was left with 5x. Now f, I ran out of room, so I put it down here. Reduced it, I ended up getting 5 square root of 2. So again, if you're getting your answers wrong, look closely at my work. Now, f does not follow the third condition, and the third condition we're going to go ahead and do on the next page. So, on this one, condition number 3 says there can be no radicals in the denominator. So if you look, I have a radical in the denominator. So that was the answer to the previous question. Well, there's this really cool thing that we do called rationalizing the denominator. What we're going to do with this problem is we're going to multiply the problem by a form of 1. And what we're going to do is we use the radical in the denominator to help us get rid of that radical. So from there, we then use the first rule and pull out any perfect square factors that I might have left. So the reason it's okay to multiply this thing by 1 is because it's not actually going to change it. Now, we're not just going to write times 1 because we're just going to get 5 square root of 2. We want a form of 1. So if you think about forms of 1, like 5 over 5 is equal to 1, 8 over 8 is equal to 1, negative 12 over negative 12 is equal to 1, right? So if I multiply anything by 1, it doesn't actually, it just sometimes changes the form of the problem, but it doesn't actually change what it's worth. So I want to point out that the square root of 2 over the square root of 2 is also 1. So what I'm going to do with this problem to rationalize the denominator is I'm going to multiply the whole fraction by the square root of 2 over the square root of 2. The reason that's legal is because that's equal to 1. Now the reason I did that is because when I multiply the square root of 2 times the square root of 2, reminder, that gives you the square root of 4, and the square root of 4 is just 2, right? So remember, when you multiply 2 square roots together, it cancels out the square root symbol. So that's why I chose the square root of 2. So then the answer here, I multiply the tops. 5 times the square root of 2 is 5 square root of 2. The bottom, the square root of 2 over 2, is just 2. And now what I have is just a different form of this number. These two things actually equal each other. It's just that this now doesn't have a radical in the denominator because we don't like weird things in our denominators. We don't like negatives in our denominators. We just want nice, pretty whole numbers in our denominators. So the next one, it looks very similar, except the top is also a radical. You're still going to do the same thing. What's wrong with this is you can't have the square root of 2 in the denominator, so I've got to get rid of it. So to do that, again, I'm going to multiply the top and the bottom by the square root of 2. Now on the top, since both 5 and 2 are radicals, put them together to get the square root of 10. And on the bottom, the square root of 2 times the square root of 2, well, the radical cancels out to just give you 2, because that is the square root of 4, and the square root of 4 is 2. So we're just taking a shortcut there. And now we're finished with that one. So the next one, think about it. What are we going to multiply the denominator? What are we going to multiply by? Since the denominator is the square root of 10, and I want to get rid of the square root of 10, that's what you're going to pick, the square root of 10. So I'm going to do the square root of 10 over the square root of 10. Now on the top, the 7 is not a radical, so it just stays 7 square root of 10 on the top, and on the bottom, the square root of 10 times the square root of 10 is just 10, because that's actually the square root of 100, and the square root of 100 is 10. The next one. The first thing I would try to do here, since they're both radicals, I would see if I could reduce them, but 2 doesn't go into 21, so I don't have to do that. I'm just going to multiply the top and the bottom by the square root of 21. So you multiply the top, they're both radicals, so you get the square root of 42. Then you multiply the bottom, the square root of 21 times the square root of 21 is just 21. Now I would pause here for a second and look at 42 and ask myself, is there a perfect square that goes into 42? Because if there was, I would have to pull it out, but there is not. So I'm finished. Let's move on to the next ones. All right, so the next one, we have the square root of 6 on the bottom. Again, we can't reduce this because the 5 on the top and the 6 on the bottom, there's nothing that goes into 5, 6, right? So we're just going to start right away by rationalizing the denominator. So we're going to multiply the top and the bottom by the square root of 6. Now the top, the square root of 5, times the square root of 6 does give me the square root of 30. Now on the bottom, you have this 4. Well, what you're going to do is multiply your square roots of 6 together first. So the square root of 6 times the square root of 6 is just 6, right? And then you have a 4 there. So you do 4 times 6. So then your answer is the square root of 30 over 24. And then that would be your final answer. The reason I'm not dividing the 30 and the 42, remember, is because the top is a radical and the bottom is not. So you can only put radicals with radicals and normal numbers with normal numbers. All right, take a look at letter F. So if you look, I've actually starred F and G because both of those problems are exactly the same. There's a reason for that, because there's two different ways that you could actually go about this problem. Now, many of you are probably going to look at this problem and immediately say, I have to get 12 out of the denominator. So that's the first way I'm going to do, where we just get 12 out of the denominator. So I'm going to multiply the top and the bottom by the square root of 12 to start with. Now when I do that, I'm going to get on the top 2 square root of 12, and the bottom is going to be just plain 12. Now, I'm not finished with this problem for two reasons right now. One reason is this radical right here, the square root of 12, it's not fully simplified. It has a perfect square that goes into it. Another reason is that this 2 and this 12, because they're outside the radical, we could reduce that. So the first thing I'm going to deal with is this guy right here. We can deal with this at the same time. So what I need to do is I'm going to reduce this to 1 over 6. And now that 1 on the top, we don't need to put there because we already have the square root of 12. I'm going to take the square root of 12. I'm going to break that into 4 times 3. And now the bottom I have is a 6 because I canceled out. I divided this 12 by 2. And then I have the square root of 4 is 2, so that comes out to give me 2 square root of 3, that whole thing over 6. And then if you look further, I'm still not finished because 2 6 reduced to 1/3. So my final answer here is the square root of 3 over 3. And that is my fully simplified answer. So it's kind of a lot of things you got to think through. Now this problem, I personally think, is easier if we decide to simplify the denominator first. So if you notice that the radical in the denominator has a perfect square that goes into it, then go ahead and do that first. So rather than multiply the top and the bottom by 12 here, I'm going to take that square root of 12, I'm going to change that to 4 times 3, the square root of 4 times 3, and then I'm going to rewrite it. So I'm going to have 2 on the top, and on the bottom now I'm going to say that that's 2 square root of 3. Then I can get rid of the radical in the denominator. So now, instead of multiplying by the square root of 12, I'm multiplying the top and the bottom by the square root of 3. When I do that, on the top I'm going to have 2 square root of 3, and then on the bottom this gives me 3. And I'm going to have 2 times 3, which is 6, but the reason I'm not writing 6 is because these 2's cancel out. So you could have canceled those out at the very beginning if you wanted, and then you end up with square root of 3 over 3. So I personally think this way, if you notice that you can do that to the denominator, that way is less steps, okay? So now let's go ahead and try that with h. If you look at h, your gut might tell you, well, let's multiply the top and the bottom by the square root of 20. But if you think about that, the square root of 20 has a perfect square that goes into it. It's 4. So I would start by making the square root of 20 into 4 times 5, and then rewriting the problem as 1 over 2 square root of 5. And now I'm going to multiply the top and the bottom by the square root of 5. And when I do that, 1 times the square root of 5 is just the square root of 5 on the top. On the bottom, the square root of 5 times the square root of 5 is just 5, and 5 times 2 is 10. All right? So now you could have done this problem by multiplying the top and the bottom by the square root of 20, but you would have had to do a lot more simplifying at the end to get the correct answer. Okay, so go ahead and stop the video right now and just try the next two problems. Try I and then try J, and then come back and see if you've got the right answers. Okay, so if you take a look at these two answers, if you've got them right, awesome. If you don't have them right, then maybe look at my work to see if you figured out what I'm doing. I am actually trying to do this in the least amount of steps. So again, since I noticed 45 has a perfect square that goes into it, so I broke that into 9 times 5. I made that 3 square root of 5. Then I canceled out the 3 on the top and the 3 on the bottom because that's 1. I rationalized the denominator by multiplying the top and the bottom by the square root of 5, and I ended up with the square root of 5 over just plain 5. Now, if you did the problem a different way, you still should have ended up with the square root of 5 over 5. So maybe if you started by multiplying the top and the bottom by the square root of 45 and you didn't get this, keep looking at your work and see if maybe you didn't fully simplify something. Now, letter J. Again, I reduced this fraction. So I fully reduced 36 over 84. They're both divisible by 12. So that's what I did. I divided by 12 and I got 3/7. Then I got rid of the radical in the denominator and I ended up with this. Now it's possible if you didn't reduce your fraction all the way, you would still end up with the square root of 21 over 7. It's just that you would get it by doing a little bit more simplifying towards the end. Okay? All right, so for K, I just wanted to point this one out. You've got stuff on the outside, you've got stuff on the inside. So I wanted to remind you, before you try this problem, you want to reduce this completely, and then get rid of the radical in the denominator. I also wanted to remind you for L, when you look at the square root of 50, before you multiply the top and the bottom by the square root of 50, simplify that square root of 50 first. It will make the problem much easier. So now that you've got those reminders, stop the video, try K and L, remembering to fully simplify before you start. Okay, so here are the answers to the last two. Again, if you didn't get these, look at my work. There's lots of different ways that you could have gotten these right answers. This is just my personal opinion, the fastest way. In this step right here for letter L, if you wanted to make this 2, you could, and then you would still end up canceling out 2's at the end. So there's lots of different ways to get the right answer, but this I feel like is the most straightforward. All right, let's keep going. For this last group of problems, I would like you to try them completely on your own. Go ahead and try all 4 of them, and when you get to letter P, there's 4 or 5 different ways you could start this problem, so I'm going to end up explaining that one and give you like 2 or 3 of the ways that you could do this problem. So go ahead and stop the video, give them a try, see what you think. Okay, so here are the answers to M, N, and O. Double check, make sure you've gotten them right. Again, if you're really getting stuck on some of these, you should probably ask for some help. So let's look at P. So the correct answer to P is 10. So there's so many ways you could go about this. So one way is you could multiply 4 times 5 times 15 together, but I don't want to do that because I don't have a calculator in front of me. So I'm going to try to make this problem easier on me. So right off the bat, I notice that this square root of 4, well, that's a perfect square. So I'm going to make that 2, right? And then I'm also noticing that the 15 over the 3, that can be reduced to the square root of 5. So I have another square root of 5 on the top. So I have like this on the top, 2 times the square root of 5 times another square root of 5 if I simplify this. And then this is just 5, right? And 2 times 5 is 10. All right, so that's one way to get it. The other way, if you did grab your calculator and multiplied 4 times 5 times 15, well, that gives you the square root of 300 over the square root of 3. We'll divide and you get the square root of 100. And the square root of 100 still leads to 10. There's lots of different ways. Like you could have found the square root of 4 is 2. You could have multiplied 5 and 15 together and then divided it by 3, and you would have gotten the square root of 25 here, which is just 5. There's lots of different ways to do it. So before just like multiplying everything together, see if you can cancel anything out, see if you can already pull out perfect squares. That's another way to do it. All right, so hopefully you're getting all three of the rules. You will have to be able to tell me what all the three conditions are on a quiz or a test, so make sure that you've got those down. All right, good luck with the rest of your assignments.